So you should have seen this method of solving simultaneous equations at school. Have you seen this?
I definitely, yeah.
Okay, so you've got your two equations that you're trying to do simultaneous equations. You realise that if you double this first one and triple this second one, then the x's will end up the same, and then you can kind of subtract downwards and get the y, hooray, and then you can sub the y over here, sub the y back in to one of the equations, then that gets you the x, and then you've got both the x and the y. It's really important to not forget to get the other coordinate. So you've seen this method, and this is great and everything, but it doesn't work for anything more complicated than the sorts of equations you get at GCSE. So we need a more sophisticated method. Okay, that's what we're going to do today. So I'm going to show you the method with these two equations, which I know you can do the GCSE way, but it just demonstrates the method. So what we're going to do, if I talk you through it, do you want to have a go? Pick either equation, they're both equally easy, and write it down, whichever one you fancy.
Okay. Start with the top one then, right?
Yeah. If one looks easier, then pick that one, but if neither one looks easier, then whichever one you fancy. Okay, rearrange it to say either x equals or y equals, and it's totally up to you which.
I like x is better. So,
okay.
I know that 2x is 10 minus 3y.
Yeah.
So x is, 10 divided by 2 is 5,
yeah.
And then 3, 2, 1.
Perfect. Now what we're going to do is we're going to insert this here. What you've just found is x. So this is x. And we've used this equation now.
Yeah.
That's been used. So what we're going to do is put this information into the second equation in this position here.
Okay.
So you're going to write the second equation, but where it says x, you're going to write 5 minus 3 over 2y because that is x.
Right, so we've still got 4.
Yeah.
And then we've got x. So that has got to be 5 minus 3 over 2y.
Yeah, that's it.
And then we've got y. And
yeah, and then you just solve that equation.
Right, multiply out the brackets, that's 20. Then 4 times 3 is 12 divided by 2, so 6.
Yeah.
Put a minus on there. Y plus y is 20.
Yep.
So 20 minus 5y is 20.
Yeah, I'll just move that for you. Out of the way, you got a bit weird.
Right. 20 is 20 plus 5y. What's the y not? 0. 0 is 5y, so y is 0.
Perfect. And then you can take exactly the same as you did in the GCSE way. Once you've got one of the answers, you can use either of the equations. Again, if there's an easier one, use the easier one to get the x. So have a look at the two equations, pick whichever one you want.
Well, if y is going to be 0, then 2x plus 3 lots of 0 is 10.
Yeah.
So x is 5.
Yep. Done. So the answer is 5, 0. Exactly. So, I mean, this, you may be watching this and just thinking, well, oh my God, well, the other way is much easier. So I'd rather do the GCSE way. And you're probably right, but as I say, you can't use the GCSE way for more complicated situations, so you do need to use this method. So, another way, yeah, these are the 4 ways we could have done it. You know, I gave you the option of choosing equation 1 or equation 2, and then I gave you the option of rearranging it into x equals or y equals. So, pause the video and have a go at doing it a different way from the way that you just saw. So just pick any other way, pick one of the other equations or pick the same equation but rearrange it into y equals instead of x equals, sub it into the other one and just check that you can get the same answer out of it. Pause the video, do the work.
We'll know.
So, what are we actually doing when we solve simultaneous equations? That's the method, that's the A-level method. But what we're doing is we're finding the value of x, which gives the same value of y when put into each of the two equations. So we've got these two equations to start off with, 1 and 2, and we're looking for a value of x, and we found it, we found 5. And if we sub the x is 5 into the first equation, then the same thing happens if we sub x is 5 into the second equation. So we get y is 0 on the second equation, we get y is 0 on the first equation. So that's what we're actually doing. We're finding one x, which in both equations gives the same y.
Or I guess 1y.
Yes, yeah, 1y, which when subbed in gives exactly the same x, exactly. So this gives us another way of thinking about what simultaneous equations are actually doing in terms of graphs. So when we've got the graph of equation 1, here's equation 1, which looks like this, and we've got equation 2, which when plotted, looks like that, when sketched, looks like this. So we're trying to find an x, which gives the same y. So we're trying to find a place where the coordinates of both graphs match up. So we found out that it was 5, 0. So what we're actually doing when we solve simultaneous equations is finding out where graphs cross each other. So that's really what we're actually doing. So there's the algebraic method, and there's also the understanding of why we would bother doing it. So let's make it a little bit more complicated. I've put a squared on the y of equation 2. Now, we know from our discussion a minute ago that we're trying to find out where two things cross each other. Equation 1, in this case, is obviously a line.
Yeah.
What does equation 2 look like? Do you know?
Well, if the square was on the x, it would be a problem. It would be a curve.
Like this.
Like that.
Yep, that's right. Yep. So we could think of it as looking like this.
But it isn't that, is it? Because it's not x squared.
Yeah, it's not x squared. What actually happens when you square the y instead of the x and have y squared and x instead of x squared and y is that our parabola is going to turn round, basically. But we are still looking at the same idea. We've got a parabola, a quadratic curve, and a straight line, and we're going to see where they cross each other. That's what they look like. Now actually, because I've plotted them really properly on autograph, we can actually cheat here and see the answers. So the answers to these simultaneous equations are 5, 0, and what's this one? Minus 4, 6. I think it might be 6. I think it's 6. I think it's minus 4, 6. So unless we go wrong, I think these are the answers we're going to get. We're going to get x is minus 4 or 5, and y is 6 or 0. But when you're giving your answers, you should give them as coordinates. So there's
Pairs,
yeah, as actual pairs to show that the minus 4 links to the 6 and the 5 links to the 0, not just a couple of numbers and a couple of numbers. Okay, let's see if we can do it. So we're going to do the same thing. We're going to have a go. We're going to pick an equation. Now, we always pick the easier one. Last time they were as easy as each other. Now there's an obviously easier one.
Isn't it?
Yep.
It's great, isn't it?
So we're going to write that one down and rearrange it to say x equals or y equals.
Well, let's go for x equals, because we know what that one is, don't we? That
Yep,
was
yep.
5 minus 3 over 2, 1.
That's it. And then we're going to do the same thing. We're going to sub that in here. So wherever it says x, we write what x is, which is 5 minus 3 over 2y.
So 4 again, 4 lots of 5 minus 3 over 2y plus y squared.
That's it. Expand out the brackets, get it all on the left-hand side.
20 minus 6
Yep.
Right.
So let's write it in a nice order. Y squared minus 6y
6y
equals 0.
0. Yeah.
Okay, so we've got a quadratic to solve.
Uh-huh.
We always solve quadratics in one of 3 ways. Factorising, complete the square, or formula. I think in this case you can probably factorise it quite easy.
It's y common, so
Excellent. So y is
y is 0
or y is 6. Perfect. So if we look back, check, because we already sneakily knew the answers, didn't we?
Yep.
So we've got the 6 and the 0. Fantastic. Correct. So once you get your 2 answers, or 1 answer, whatever it is, for y, you remember to take these back to the easy equation. Always use the easy equation to get the other coordinate. So when y is 0, x is
5.
yep. And when y is 6, x equals,
Well, that's probably it, isn't it? 6. X equals minus 4.
5 take away 6, no, hang on, what? 9. 5 take away 9 is minus 4, yeah.
2 times, 3 times 6 is 18 divided by 2 is 9.
5
Minus
take,
9,
yeah,
5 take 9.
I agree with that. And also, we agree with that because that's what we decided we would get. Yay! And there they are paired up. Fantastic. Good. Wasn't that bad, was it? So, again, there are different ways of doing this, and it doesn't matter which one you choose. So long as you start with the easy equation, you could put it into the form x equals like you did, that's this option we just did, or you could put it into form y equals. So pause the video now and do the same thing, but when you do it, instead of making it x equals, make it y equals, that easier equation, and substitute that in. It's a bit more messy, but see how you get on, see if you can solve it and get the same answers. So pause the video, have a go yourself, and then unpause the video when you're done. Okay, made it a little bit harder again by sticking a squared on the x as well as the y. So we've still got a straight line, that's equation 1, it's a straight line. Do you know what shape equation 2 is?
Well, x squared and y squared, if you have an x squared and a y squared, then it's circular.
Yep, x squared plus y squared equals r squared. That's the equation of a circle.
But as a 4.
Yeah, so it's kind of like we've got a circle and a line, but we know that the 4 here is going to do something, so it's not quite going to be that, but essentially we're looking at some sort of circular thing and a line, and we're going to try and find out where they cross. Okay. So when they're plotted, they look like this, and you can see that what that 4's done is to stretch the x direction out. So it was a circle, but this 4 has stretched it that way, so it's become an oval, basically. So let's see if we can cheat again. The answers are going to be 2, 2, does that look like?
Yeah, that looks like it to me.
And
Minus 1, 4.
minus 1, 4. Okay, hopefully, when we solve these simultaneous equations, that's going to be the answers that we get, because that's where these graphs cross each other, and that's what we're doing with simultaneous equations. So, off you go. Start with the easy one. Make it say x equals or y equals.
Okay, so x is still 5 minus 3 over 2y. I think
Yep.
we'll be able to get this.
And then we're going to substitute that in very carefully here.
Okay, so we've still got a 4. And now our x is 5 minus 3 over 2y. But that's been squared.
Yep, that's right. The whole thing's being squared.
And then we've got y squared.
Yeah.
And the 20 on the end.
Yeah, that's it. Now we're just going to have to be really careful here and go super slowly and, you know, see what happens.
Yeah. Okay, I'm moving forward it is.
Yeah, leave it for where it is.
Nice big bracket. Okay. Well, that squared means run the bracket out twice, doesn't it?
Yeah.
I don't want to make any mistakes, so I'm going to go the long way.
That's right. That's what squaring means. So it's, what's really important is that you do not, and I'll write this and then rub it out immediately because it's really bad, make the classic mistake of thinking that when you square things, you can just square them individually. I mean, even this is bad on so many levels, it's not even true. Because you can't just go, oh, well, I'll square that and I'll square that for a start. Secondly, if you did square 3 over 2y, you wouldn't get 3 over 2y squared, because you'd be doing 3 over 2y times 3 over 2y, which would be 9 over 4y squared anyway. But even if we corrected that mistake and made this 9 over 4, it's still nonsense, because that's not how you square brackets. You square them using FOIL method is usually how it's taught at GCSE. FOIL or however, this with this, this with this, this with this, this with this.
Yeah.
Yeah.
Well,
Oh, let's have the plus y squared equals 20 and keep the whole equation. Yep, great. Okay, good luck.
Right, so,
Should we keep the 4?
yep.
I like the big square bracket, this is good.
Right, so now we've got 5 times 5, which is 25, that took
Yeah.
me a moment. And then I'm going to do 5 times, so that's 5 times minus 3 over 2, so it's minus 15 over 2.
Yeah,
5
it might
times
just
3.
be worth me just explaining how you did that so quickly, because sometimes students struggle with this. 5 times, I mean it's negative, but ignore that for a minute, 3 over 2y. Fractions times fractions, yeah, students are fine with. Whole number times fractions sometimes can be a bit confusing, so the easiest thing is to think of it as a fraction times a fraction times y. And then you can see that you've got 5 times 3 on the top, which is 15, and 2 times 1 on the bottom, which is 2, lots of y. So that's just something that sometimes students aren't entirely sure how to do that.
Okay,
Yeah, so we've got minus 15 over 2y.
and then we've got it again.
Yep, from the other middle bit.
Yep. Okay, now minus times a minus is a plus.
Yep.
And then we've got 3 over 2 times 3 over 2, which is 9 over 4.
Yeah.
And then we've got a y times a y. That's
Perfect.
Close a big bracket, add a y squared.
Yeah. Great. Let's create a bit more room here. Okay. Expand out big square brackets.
Right. I'm going to collect together middle terms.
Oh,
first,
good
I think.
idea. Good idea.
So that is minus. What is that? 50,
Well, it's minus 15 halves and minus another 15 halves, so it's minus 30 halves, which is
50.
minus 15. Yeah.
That's nice to sort itself out, isn't it? So that's what's inside our big bracket, isn't it? And we're going to multiply that by 4.
And the 25.
And 25. So all of that has got to get multiplied by 4.
Yeah. And then another one. And then, yeah, always keep the whole equation going so we don't lose little bits along the way.
So that's 100 minus 60
Yep.
y, that took a while, plus 9y squared.
Yep.
Right,
Plus
that's everything in
9
that.
divided by 4 times 4. Yeah, it's just 9. Yep. Plus another y squared.
Right, and then we're out of the bracket.
There we go. So,
Let's go to y squareds.
yeah, and then we can write it in a nice order. Maybe
Okay.
the y squareds first and...
So we've got not 100. That would be large. 10 y squared minus 60y
Yeah,
plus 80
yeah, because the 20 comes over.
Yeah.
Now we can solve this. It's a quadratic, so we're going to factorise, complete the square, or use the formula. But because everything is divisible by 10, it might be nicer, and we've got equals 0. So if we divide everything by 10, left-hand side and right-hand
Yeah.
side, then the equation still holds, and it might be nicer to solve.
So 10 divided by 10 is just 1, so y squared, and that becomes 6y, and that's an 8, and that does look a lot
There we
nicer,
go.
doesn't it?
Right. Factorise. Factorising is always nicest if possible. I think it's going to be a 4 and a 2 somehow.
Well, yeah, 2 times 8 is minus 4 minus 2.
Yep, I agree with that. So,
So
y equals...
Y equals 4 and 2.
Yeah. Is that what we got? Yes. Yes. Y is 4. Y is 2. Great. Okay, so let's now take our y solutions and always go up to the easier equation. Actually, specifically, the rearranged form of the easier equation, and then use that to find out. Have we got room?
Yeah,
Just about.
just about.
So when y is 4,
So when y equals 4, x is 5 minus 3 over 2 lots of 4.
yep,
So that's 3 times 4 is 12 over
Mhm.
2, so 6. So 5 minus 6 equals minus 1.
yep,
So that coordinate then, minus 1, 4.
yep,
I like writing them then, because otherwise I forget which one
Yeah.
is what. And then y equals 2. X is 5 minus 3 over 2 lots of 2, which is 5 minus 3, because they cancel each other,
yep.
which is 2. So, 2, 2.
Which is what we've got, minus 1, 4 and 2, 2, minus 1, 4, 2, 2.
Brilliant.
Perfect. So we found where the oval crosses the line. So, I mean, this is, compared to GCSE, this is a lot of algebra.
Mm-hmm.
From an A-level point of view, it's not really much algebra.
Yep.
So this is the sort of thing that after really the first couple of weeks of starting the A-level, you should be able to manipulate this sort of level of algebra quite easily. Maybe have to slow down a bit in the middle to keep control of it, but not getting bogged down by this level of algebra. Okay, so we rearranged the easier equation into the form x equals. We did this method, but you could just as easily have rearranged it into the form y equals. So pause the video now, rearrange the first equation into the form y equals, substitute that into the second equation, and just see if you can do this, see if you can get the same solutions. Yeah, good luck, but actually do it. Okay, well, I'm assuming that you did that previous one and got it right, so well done. And here is a summary for you to write down in your notes how to solve simultaneous equations using the A-level method. So you're going to write down the easier equation, rearrange it into y equals or x equals, it's up to you, sub that into the more complicated equation, solve that, and then use that in the easy equation. Always use the easy equation to find the other coordinate.